Hello, this is Mr. Boyer again, and today I'm going to be talking about this learning target 09-73204, and we're just going to go a little step further on our discussion of basic probability from last time. So this learning topic says to develop a uniform probability model by assigning equal probability to all outcomes and use the model to determine probabilities for events. So a lot of big words here, a lot of vocabulary that we need to understand. One word that's not in there that we need to understand is probability model. Probability model, oh by the way, check out this video if you haven't already, it's a good one. But first off, probability model, let me zoom in a little, well no that was good first, yeah. A probability model, probability model is just a representation, T-I-O-N, of a random phenomenon. A random phenomenon. You know what a phenomenon is? Fancy word for event. So what is an event? An event is just the occurrence you are calculating probability for. So an event is the occurrence you are calculating probability for. What that means is anything that happens, something that happens. So examples are rolling a dice. So rolling this bad boy, the event is rolling the dice. And what I just got here, that's called an outcome. So an outcome is any result for an event. So the outcomes for this, for rolling a dice, so for rolling a dice, all the possible outcomes are 1, 2, 3, 4, 5, and 6, because that's how many sides there are, and that's all the possible outcomes. So that's what an outcome is. Next, let's talk about experimental probability. What is experimental probability? Experimental probability. Experimental probability. An experimental probability is basically just what it says in this name, experimental. What does experimental sound like? Like doing an experiment, right? So experimental probability is calculating the probability. Man, I hate writing probability. It gets all right here, it's like slappy. Probability based on an experiment. So any kind of experiment. So I'll give you an example. So let's say an example is I don't know, Mr. Boyer missed some kind of a, let's say I was shooting arrows or something and I missed the target 5 times in, let's say, 40 shots. So I missed the target 5 times in 40 shots. that's an experiment right there. I just did something, and now I have 5 and 40. So what is the probability Boyer will miss his next shot? So what is the probability that I'll miss my next shot based on this experiment? So the experimental probability would be, well, how many did I miss? 5 out of the total amount. So I would say probability of a miss would be 5 out of 40, which you can reduce. Don't forget to reduce. Let's use the giant 1. I don't know if I've gone over the giant 1 with you guys, but we use the giant 1 to see what number goes into both 5 and 40. What number goes into both 5 and 40? Like divided evenly. So 5, yes. 5 goes into 5 one time. If you do the same thing, what you do to the top, you got to do to the bottom. That's why it's called the giant 1, because 5 over 5 is equal to 1. So 5 goes into 40 how many times? Yep, 8. So 5 over 40 reduces to 1/8. So we just got done talking about experimental probability. So now we're going to talk about, let's see if that light helps a little bit. We're going to talk about the next type of probability, which is called theoretical probability. And theoretical probability, just like experimental probability, well, the first word kind of gives it away. Theoretical. What does that sound like? Does it sound like theory? So in theory, like, what should it? So the probability, probability, and the probability an outcome will happen based on reasoning or calculation. Oops, it's all crooked. So the probability an outcome will happen. So the probability of something happening based on reasoning or like in theory. So an example would be if you draw a card out of a deck. So if you draw a card out of a deck based on reasoning and calculation, let's say the probability of picking a red one. Well, how many cards are there? 52, which half of them are red, half of them are black. So that would be 26. And I just kind of gave it away. We can reduce that to half. And that is not based on past results. Not based on past results. So there was no experiment done. No one drew cards before. We just already know that there's 52 cards. Half of them are red. That's the probability, the theoretical probability. Another one would be rolling a 2 on a dice. So probability of getting a 2 on a dice, well, we know we can roll this 7,000 times and there's always going to be 1 2 on the 6-sided dice.